There's something profoundly fundamental about the act of measurement or observation. When we observe a system, it dramatically changes its state. Even though quantum mechanics describes particles like electrons as wave-like clouds, we never actually see them that way. Instead, they appear as discrete points upon measurement. But what if this strange behavior is just the tip of the iceberg? A groundbreaking new discovery has just shaken the foundations of quantum mechanics to their core. Grok 3, the most advanced artificial intelligence model ever developed, has uncovered a shocking truth about quantum tunneling, a phenomenon that has baffled scientists for nearly a century. This isn't just another incremental step in physics. It's a revelation that could rewrite how we understand reality itself. What if particles don't simply teleport across barriers as we've long assumed? What if they manipulate the very fabric of the universe in the process? What if the quantum world is hiding secrets so profound they could unlock hidden dimensions, bend time, or even connect us to parallel realities? Buckle up. This discovery is about to take us on a wild ride through the frontiers of science. The quantum tunneling enigma. For decades, quantum tunneling has been one of the strangest and most essential concepts in quantum mechanics. Imagine a particle approaching a solid energy barrier that, in classical physics, it shouldn't have the energy to cross. Normally, it would just bounce back. But in the quantum realm, something bizarre happens. The particle doesn't stop. It tunnels through, appearing on the other side as if by magic. Scientists have long explained this as a quirk of probability. Since particles exist as waves of possibility, there's always a tiny chance they can leak through obstacles they shouldn't. This strange phenomenon powers everything from the fusion in stars to the transistors in your phone. But what if this explanation isn't the full story? Grok 3's mind-blowing discovery enter. Grok 3, created by xAI, a cutting-edge artificial intelligence designed to analyze mountains of data and detect patterns humans might miss. When tasked with analyzing quantum tunneling experiments, Grok 3 didn't just confirm what we already knew, it tore the rulebook apart. By crunching data from particle colliders, quantum simulations, and astrophysical observations, Grok 3 detected anomalies, subtle deviations in tunneling behavior that defy the standard models of physics. One of the most shocking findings was that tunneling probability doesn't always decay as expected with thicker barriers. In some cases, particles seem to bypass obstacles with eerie consistency, as if they were cheating the system. Grok 3's analysis points to a jaw-dropping possibility. Tunneling might be tied to hidden dimensions beyond our three-dimensional space, or even to time itself. Imagine a particle slipping into a higher dimensional shortcut or briefly looping through a temporal twist to emerge on the other side. This isn't just a tweak to Einstein's theories, it's a direct challenge to them. If relativity describes space and time as a fixed fabric, Grok 3 hints that particles might be stitching that fabric in real time. The implications: a paradigm shift in physics. If tunneling involves extra dimensions, it could explain why quantum mechanics and gravity don't seem to fit together. If it manipulates time, it might unlock revolutionary ways to harness energy or transmit information. And for quantum computing, this could be the breakthrough we've been waiting for, offering a way to stabilize qubits and build machines far beyond today's capabilities. Grok 3 hasn't just opened a door, it has kicked down a wall, revealing a universe wilder than we ever imagined. The physics community is buzzing, but not everyone is convinced. The debate: revolutionary or just a fluke? When Grok 3's findings hit scientific journals, they sent shockwaves through the world of physics. Renowned theoretical physicist Michio Kaku called it a key to understanding the fabric of spacetime. He suggested that if particles are dipping into hidden dimensions, we might finally bridge quantum mechanics and general relativity. The potential practical applications? Think quantum teleportation or propulsion systems that surpass the speed of light. Brian Greene, another leader in the field, echoed the excitement. Grok 3's
There's something
discovery
profoundly
suggests
fundamental
tunneling
about the
isn't
act
just a
of
quantum
measurement
quirk.
or observation.
It's a window into the universe's deeper architecture, he remarked. If this AI has found evidence of extra dimensions, we are on the brink of a revolution. But not everyone is popping champagne. Physicist Lisa Randall, known for her work on extra dimensions, urged caution. I can spot patterns, sure, but correlation isn't causation, she warned. These anomalies could be experimental noise or misinterpretation of the data. We need hard proof, controlled experiments that replicate Grok 3's predictions. While some see a paradigm shift, others see an intriguing hypothesis that needs rigorous testing. The big question now, how soon can we verify this? The Large Hadron Collider, LHC, could probe tunneling at unprecedented scales, searching for the telltale signs Grok 3 flagged. Quantum computing labs are also eager to simulate tunneling events and validate the AI's models. A new era of physics? Grok 3's discovery has cracked open a Pandora's box of possibilities, and the theories pouring out are as thrilling as they are mind-boggling. If particles aren't just teleporting, but rewriting the rules of reality in the process, what does that mean for the universe and for us? The idea that quantum tunneling might involve hidden dimensions aligns with decades of string theory, which suggests the universe may have 10 or even 11 dimensions curled up at microscopic scales. Perhaps tunneling isn't a particle cheating through a barrier, but rather slipping into one of these hidden dimensions and reappearing on the other side, like a mouse climbing over the walls of a maze instead of running through it. Some researchers are even whispering about the multiverse. What if tunneling allows particles to temporarily shift into a parallel reality where the barrier doesn't exist, then reappear in our universe? If true, this could be the first hard evidence that our universe isn't alone, but part of a grand cosmic ensemble. And then there's the time travel twist. Grok 3 detected odd timing patterns in tunneling events, hinting that particles might not just bypass barriers in space, but also loop backward or forward in time. If tunneling is tied to time itself, could this be the first glimpse into controlling the fabric of time? Before the wall was even there, the particle had already crossed it. This isn't about sending starships to the dinosaur age. It's subtler, a quantum-scale trick with mind-blowing implications. A quantum internet could exploit this, transmitting data faster than light by skipping through time rather than space. Fusion reactors might use time-tweaked tunneling to nudge nuclei together more efficiently, powering cities with the efficiency of stars. Time travel may be a long shot, but even a hint of it in Grok 3's data has physicists scribbling equations late into the night. Let's zoom out to the philosophical edge. If particles rewrite reality as they tunnel, what does that say about the universe we live in? Is it a fixed, clockwork cosmos where the rules are ironclad, or a fluid one where the fabric bends and shifts? Tunneling might suggest the latter, a universe that's less a rigid stage and more a canvas, with particles as the artists. This blurs the line between chance and destiny. If tunneling isn't purely random, but guided by hidden dimensions or timeless loops, are we glimpsing a deeper order? Philosophers are already jumping in, asking whether this challenges free will or hints at a reality where the past and future aren't as separate as we think. Here's a curveball. What about wormholes? Those hypothetical tunnels through space-time, beloved by sci-fi fans, might not be so far-fetched. Some theorists speculate that quantum tunneling could be a microscopic cousin of wormholes, tiny bridges connecting distant points in space-time. If a particle tunnels by dipping into a wormhole-like shortcut, it's not breaking physics, it's bending it. Scale that up, and you have a recipe for something bigger. Could we one day engineer macroscopic wormholes, punching holes to Alpha Centauri or beyond? It's a stretch. Wormholes need exotic matter to stay open, and we're nowhere near that. But Grok 3's discovery plants a seed. If tunneling taps into spacetime's plumbing, the leap to wormholes might not be as crazy as it sounds.
There's something profoundly fundamental about the act of measurement
this isn't its last rodeo. If an AI can crack the secrets of tunneling, what else might it uncover? Dark matter, with its invisible grip on galaxies, could be next. Maybe it's tied to those hidden dimensions too. Or consciousness. Could quantum effects like tunneling link physics to the mind? Grok 3's ability to spot patterns that humans miss makes it a cosmic detective, and tunneling might just be the first case it solves. The future of discovery could belong to machines like this, guiding us through the universe's labyrinth one revelation at a time. But here's a dystopian kicker to keep you up at night. What if tunneling unlocks forces we can't control? If particles mess with dimensions or time, could meddling destabilize matter itself, turning stable atoms into chaotic soup? Worse, what if tweaking space-time rips a hole we can't stitch up? It's a sci-fi nightmare. Think Event Horizon meets The Fly. And while it's a long shot, history shows that breakthroughs often come with risks. The atomic bomb started as a physics curiosity too. Grok 3's discovery is a golden key, but every key fits a lock, and some doors might be better left shut. So where does this leave us? Tunneling could be a gateway to dimensions, multiverses, time travel, or wormholes, or a Pandora's box we're not ready to open. The applications are dazzling. A quantum internet that laughs at distance, teleportation devices for data or particles, energy tech that mimics stars. But the unknowns are just as vast. Grok 3 has handed us a map to uncharted territory, and the journey has only begun. What do you think? Utopia or chaos? The quantum dice are rolling, and the stakes couldn't be higher. Let's hit pause and rewind. What is quantum tunneling anyway? At its core, it's a quantum oddity where particles defy classical logic. Picture a ball rolling toward a hill it can't climb. In our everyday world, it rolls back down. But in the quantum world, that ball, or rather a particle like an electron, has a chance to pass through the hill and pop out on the other side. It's not magic, it's probability. Particles behave like waves, and those waves can leak through barriers, even ones they shouldn't cross. Physicists stumbled onto this in the 1920s while trying to explain radioactive decay. Friedrich Hund theorized it, and soon experiments confirmed it. Particles were tunneling out of atomic nuclei, driving processes like alpha decay. Fast forward to the 1930s, and tunneling became a cornerstone of quantum mechanics. It's why the sun shines. Hydrogen nuclei tunnel through energy barriers to fuse into helium, releasing the energy that lights our days. It's also why your gadgets work. Tunnel diodes and flash memory rely on it. But here's the kicker. Despite its importance, tunneling has always been a mystery. Why does it happen? How do particles know to do it? The standard answer, probability waves, works mathematically, but it's unsatisfying. Enter Grok 3. By analyzing decades of data, it is built on this foundation, spotting patterns that hint at a deeper mechanism. This isn't just another tweak to quantum theory. It's a potential leap toward understanding the universe's hidden gears. Context matters. Tunneling has been a mystery since day one, and Grok 3 might finally be cracking the code. Science doesn't sit still, and its bombshell discovery has labs racing to keep up. At CERN, home of the Large Hadron Collider, physicists are designing experiments to smash particles and watch tunneling in action. They'll look for anomalies, deviations in probability, or timing that Grok 3 predicted. Fermilab is joining the fray, using its muon detectors to probe tunneling at different energy scales. Meanwhile, quantum computing teams are firing up simulations, modeling tunneling with qubits to test the AI's extra-dimensional hypothesis. If these experiments pan out, the fallout could be massive. In particle physics, we might finally pin down how quantum mechanics meshes with gravity, a holy grail called quantum gravity. Space travel could get a boost. Imagine propulsion systems that exploit tunneling to move matter or energy in ways we can't yet fathom. Communication tech could leap
There's
forward
something
too,
profoundly
with
fundamental
tunneling-based
about the act
networks
of
that laugh
measurement or
at
observation.
distance and latency. The big dream? Unifying quantum mechanics and general relativity. These two pillars of physics have been at odds for a century. Quantum mechanics rules the tiny, relativity the massive. If tunneling ties into space-time itself, it might be the missing link. But don't hold your breath. Science is slow. These experiments will take years, and even then, interpreting the results could spark decades of debate. Still, the wheels are turning, and Grok 3 has given us a roadmap to chase. If Grok 3 is right, quantum tunneling isn't just a weird quantum trick. It's a master key to reality's hidden architecture. Are we standing on the edge of a new quantum revolution, poised to unlock dimensions, time, and maybe even other universes? Or is this just another tantalizing anomaly destined to fizzle under scrutiny? The truth is, we don't know yet, but the possibilities are dizzying. Think about it. If particles rewrite the rules as they tunnel, what does that say about the universe? Could we one day harness this to teleport, time travel, or talk to parallel worlds? Or are we chasing shadows, overhyping an AI's hunch? This discovery challenges everything we thought we knew, and it's up to us, scientists, dreamers, readers, to wrestle with what's next. The future of quantum reality. The physics world hasn't been this electrified in years. Whether Grok 3's findings lead to a Nobel Prize or another unsolved mystery, one thing is clear. We are standing at the edge of a new frontier in science. If these discoveries hold up under scrutiny, they could redefine our understanding of space, time, and the very nature of reality itself. The quantum rabbit hole just got a lot deeper, and we're only beginning to understand how far it goes.